Yeah, let's do a quick review. Again, all three of us are container guys. We've done containers for a long time, and we're here today because Felipe has an awesome project that's very meta, very relevant. It's relevant when it comes to Dockerfiles, creating containers with Dockerfiles and without Dockerfiles, and it has its own Dockerfile.
which
Yeah.
we are going to review today. But
Yeah.
before we do this, Felipe, could you walk us through your awesome project?
Yeah. Well, I do not think it's an awesome project, but I just want to say that it's been awesome for me when it comes to learning more about BuildKit features and how to package Go applications differently without using a Dockerfile. And I just want to say that Dockerfiles are very powerful. They are extremely helpful. Sometimes when you need to learn as a beginner how to craft one, uh, like crafting one that gives you a very slim image, very lightweight one, it's not easy, right? I think that applies to every single tech, not only Go, could be .NET, Java, you name it. So basically, this project is about to abstract how developers uh, can write this kind of Go file, which has a different syntax to what the Dockerfile has, in order to produce an image that is very lightweight. This project is pretty much similar to another one called Dockerfile, uh, but I just added a few minor features just for my learning purposes. Okay. Um, yeah. So maybe Ivan, you want to share the screen and
Yep.
quickly go through it?
So let's jump to the project and let's just put this out. Um, oh, is my screen being shared? Because I,
Yes, but
yep.
okay, now much better now. Yeah, now it's full width.
Okay. Okay. And is the phone big enough?
Yeah, yeah.
All right. So this is the project that Felipe wrote. It's on GitHub and it's called Gofile. And as Felipe said, this project builds container images for Go applications, but it does so without using Docker files. What we are going to do today is actually reviewing the Docker file that this project uses itself. But before we jump to this part, let's take a quick look at the alternative way this project offers developers to to build their container images. So, Felipe, could you explain what's going on here?
Yeah, so I will start by highlighting the line 14, which is a special syntax here that is going to tell us how we want to interpret this new syntax, right? So you can see this is a YAML file, and it has a few fields: repo, path, ref, scratch. So
So
this is a
this
very
is sorry for interrupting. This is an alternative to a Docker file, right?
Mhm. Yes, exactly. This is what in BuildKit is called a front end, which is a different way to express how you could build a container image, right? These fields that you see here is something that are totally arbitrary. Like you could use whatever fields you want. You could use uh, different annotation, right? Different structure. Um, and in line 14, what we have is uh, let's say the brain that is going to interpret these few lines and is going to convert this piece of code, let's say, into a LLB, which is a low-level build, which is what BuildKit can understand and can execute. It's going to define a different set of steps uh, for this way to package a container image.
Right. And if I would try to write a Docker file to do kind of the same, Here is what it would look like, more or less. So what happens here is we're trying to build a Golang application that exists at this GitHub repository using its main branch, and then pack it into a from scratch container image. So to build pretty much any Golang application, you would need to start with a compiler image, I don't know, a version of Go, and then what would happen then? I think it would add the content of this repository to the context folder. Maybe let's define this explicitly. Let's say it's app, and then traditionally, I don't know. I'm just speculating here, but I would disable most of the time CGO, at least by default, and then would do something like go build -o to some binary folder, go live, right? And whatever is in the current folder. So this cannot be, well, it can, but it should not be the final result. It's more like a build artifact. And then we want to actually distribute it. So this project, Gofile, this Hello World demo app is likely just a dummy CLI tool, right? So then we can potentially put it into a from scratch image. So then we would need to copy from the build step. We would need to copy, the binary, and well, just call it, right? Oh, invoke it. Yeah.
Maybe you want to rename Go Live to Go File.
Sorry.
No, that's fine.
But in this case, it's not even this, right? It's like this.
Well, yeah.
Sorry. Yeah. So this is what we are building, and this is what we are calling actually. Yeah. So this piece and this are just different forms to write the same build instructions, right? And then BuildKit as a backend of the Docker build process in this case, and as a backend for the Go live in this case, would just compile, if you like, these instructions into some intermediate representation that then will become the actual executable steps. But what Gofile is itself, it's actually a CLI tool, which is a client of the BuildKit API. And today we're going to take a look at how this CLI tool, Gofile, is itself Dockerized. Because one of the ways to distribute CLI tools is by packing them into Docker images. So let's jump to the Dockerfile that Felipe wrote to containerize his Go file tool. We probably need to make a disclaimer. Felipe spent many years working at Docker, so this is a very solid example, expectedly, of a Dockerfile. Not much for us to actually improve here. But it also has a whole bunch of interesting tricks that Felipe used, and let's try to make them slightly more popular. Let's go through this file. Felipe, would you like to walk us through?
Mm-hmm. Yeah, sure. Well, basically, this is a multi-stage Dockerfile. We see in line 4 and line 19, we have two different from statements. The first one is basically, we're basically using a Golang image that contains basically all the developer tooling to compile the binary. The other stage is the runtime stage, which is going to ship just the binary that we have produced in the previous stage and we're going to add just a few more packages that are needed. So this is like a high-level overview. Now we deep dive into the build stage. So we can see in line 9, for instance, where we are just running a Go mode download, which is going to download all the packages that we have in our Go mode file. The interesting bit about this is a very ugly syntax, in my opinion, but very powerful. So all this run, mount, cache, bind, these are like two separate things. So with the mount type cache, what we are doing is just using BuildKit to store all the download packages into the build container. So this way, if you add a new dependency, you do not have to download all the dependencies again the next time that you do the Docker build, right? So it's just gonna cache all your packages, and it's gonna download only the one that you have added. The other mount type that you see, line 11 and 12, those are mount types of type bind, which basically is like the BuildKit container is going to have access to those files without you having to copy them over your Docker image. And this is very good because you are not going to have these two files, the Go Zoom and the Go mode, in appearing right in this build stage, because it's just going to bind mount them, run the Go mode download operation. After this instruction has run, those files won't, let's say, persist in the container image layer. I think that's, I don't know if you want to add anything, Ivan, here to this instruction.
We can probably go over them a bit later. I would focus on the higher level kind of idea of this stage, right? This is a build stage. But why? Why do we even have it? Because at this point we have our Gofile CLI compiled, right? Why not to just go like this? I know where is it stored at bin Gofile. Yeah, why not to do just this and then get rid of all this stuff?
Yeah, you could do that. As you know, we are using a base image, which is Golang, that contains a lot of stuff, a lot of files, a lot of dependencies that we do not want to ship as part of a production image, right? Maybe it even contains a shell, I don't know, but those are things that introduce like also more vulnerabilities, because the more, let's say, files that you have, dependencies, then that attack surface is wider, right? So it's always a good practice to just ship to production a container image that has only the stuff that you want, that you need, and nothing else.
Yeah, that's a very good point. And if I understand the purpose of this Dockerfile correctly, the artifact, the build artifact that we're trying to create here is this single binary. And this binary is statically linked, so technically it doesn't even need any system libraries to run. And at this line, like 22, 23, we already have this binary compiled, but it exists in an image that it was started from the Golang compiler image. And this compiler image is huge. It's at least 1 gigabyte big, and it has not just the shell, but it has like hundreds of different build dependencies. So as a result, at this place, we would have our Gofile as like a fraction of a percent of a payload in this image. So what we are doing instead we're trying to produce the final container image that will be actually pushed to the registry and then pulled by the users, that contains only the build artifact, which is a single binary in our case, and only the necessary dependencies. So let's like never do this, right?
Yeah, I just check. Is 130 megs the size of the Golang image?
The compressed one, right?
The compress, yes.
Yep. So it's about 1 gigabyte, I guess, when uncompressed then. All right. So next stage. What actually happens here, right? But by the end of this stage, we had the binary file stored at this location. How we actually transfer it?
Sorry, say again?
So how we actually transfer this file from this build stage to the runtime stage?
Yeah, so in line 46, we have this copy instruction that the Dockerfile syntax gives us, which allow us to specify the name of the stage as part of the from flag, and then you can just grab, you have like the next two arguments is the source and the destination. So we are saying, give me the /bin Gofile from the build stage and place it in the bin directory of this runtime stage.
All right. So in a way, it's rather simple because we use a good old copy instruction, right? But then the copy instruction, well, I think for most of us, copy is something you use to actually copy from your current folder to the image, right? That's probably the most typical thing to write in a Docker file. I do it like multiple times a day. Sometimes you're being more specific. You're saying, hey, I'm copying only a certain file or maybe a few files, right, into my image. But it looks like you can also copy from some arbitrary locations, right? It's not your local folder. It's another stage here, right?
Mm-hmm. And also another image. You could specify another image as well if you wanted.
Oh, right. So it actually could have been something like from, it's not like it's needed here, but it could have been from Nginx latest, right? You could actually copy the Nginx binary to your current image, right? Yeah. All right. And then if this is how we copy from the build stage, it looks like that the only thing we copy from the build stage, because I don't see any other copy instructions, is this single file. Am I right?
Yes.
Yep. Looks like it, right? So then this is a statically linked Golang application. And we're not copying anything else. And at the same time, we're placing it into a new image. And this image is Alpine based. Could you explain your choice? So this is actually going to be your actual base image, right? For your production stage.
Yeah, there are a couple of things here that don't look right, but I think it's convenience. So in this case, using Alpine is convenient because it's kind of a small image, although not as small as a Scratch image, of course. But it gives you the ability to, for instance, install CA certificates, that package using APK. For instance, if my Go binary needs to make a request, HTTP request, I'm going to need to have that package installed, right? So it's very convenient and easy, right? To just use as Alpine to install those certificates and then have them in the runtime stage. Yeah.
So, what are the gotchas usually that you have to deal with when you're considering Alpine? because that's one of the questions that'll be good to explore.
Yeah, that's a great question, and like for this particular example, well, as Felipe said, right, what we cannot use here is something like this from scratch. Yeah, no, almost. So this is what we cannot do, at least without doing something extra. But why? It's because even though this binary is a statically linked application, it would run in a Scratch container, which is an empty folder. It would run there, but the moment this Gofile tool would try to access, let's say, BuildKit over some HTTPS endpoint or some other destination, it would fail because there is no CA certificates in the Scratch image unless you put them there explicitly. So this is why we are not using, or Felipe is not using a Scratch here. And this is why Felipe is using Alpine, which is a minimalistic Linux distribution. But why not to, Alpine has some reputation for what it worth. Why not to use here something like this? I know, Debian Bookworm.
I guess that you could, but I think there are images that are heavier, right?
Yep.
It contains a lot of more dependencies.
Well, in terms of the light container images, obviously Alpine is one of those, and then the other one we have is BusyBox, right? Where you get a shell and all of that, but you don't necessarily get the certificates, right? But you can get the certificates there the same way you get the binary in there. You can have a stage potentially, or maybe even the same build stage where you grab the certificates and then you copy them as well.
Yeah, I think this is one of the big questions that we have in our industry. Like, what's the best base image that you could use, right? There are like different ways to compose them, or it's always very difficult to come up with the perfect one that has the minimum amount of stuff that you need, right? Yeah, pretty much a lot of them are going to work, but I do not think we have the tools to quickly inspect or see what is the base image that is most suitable for your needs easily, right? Because right now you're asking me, why not, why Alpine? Why not Debian or any other, right? We do not have, I think, a good way to visualize what's inside them. You could use Dive and go one by one and compare them, but it's not straightforward. So it's not quick.
Yeah, ideally you'd be able to ask a question, or you would make a statement. This is what my application needs. What is the best base image that delivers me those requirements? For example, let's say I only need a shell. That's all I need. Which one should I use?
Exactly.
Yeah. So then Alpine sounds like an optimal choice for this particular case because, again, unlike BusyBox, which also comes with a shell, right? Alpine has already some certificates installed. You can refresh them by reinstalling them, but it's all is easy doable because there is a shell and there is a package manager in this image. And at the same time, the image is only 5 megabytes big, so you don't really care about the overhead because 5 megabytes is like pretty much nothing compared to 120 megabytes of the Debian image. There are, of course, some caveats, right, when it comes to Alpine. And one of the biggest is probably that it uses muscle instead of libc, right, for the C standard library implementation. It is a valid downside. Well, depends, right? If you are a power muscle user, then it may be an upside for you, right? For the rest of us who actually is used to rely on libc, accidentally running in some differences in behavior and or performance of muscle may be more painful. But for this particular example, for the Gofile application, does it even matter?
Maybe not.
Yep. So that's exactly the point here. If, as a developer, you understand the requirements and dependencies of your application, you can then dismiss safely some of these potential downsides of the base image. Gofile is a statically linked application, so it does not depend on any system libraries. And then there is an alternative libc implementation in the Alpine image, but we don't care, right? Gofile does not depend on it, so yep, no hard feeling about this part. Then there might be something else, and I think before Go 1.16 or something, there was like a gotcha with the Go DNF resolution logic that would behave differently in images without the etc nsswitch.conf file. Again, not relevant anymore because the net module was rewritten completely. In Go, there is no dependency, there is no discrepancy in behavior, so looks like we're totally safe to go with Alpine.
Mm-hmm.
What else do we have here? So we've got a minimalistic runtime stage. It uses Alpine as a base. It's a valid choice for our particular use case. And that's where we actually copy the binary into our final image. But we have quite a bit of things also going on here. Could you walk us through the rest of them?
Mm-hmm. Yes, from line 39 until 44, we are installing some packages using the package manager of Alpine, APK. As I said before, we're installing the CS certificates so that we could make HTTP requests from our binary. We're using the time zone data just in case we need to grab time zone information as well. And what more? We're using the mount type cache, similar to what I discussed before, because we want this instruction to be cached so that if I add a new package in this list next week, then I'm not going to be downloading all the packages again. And yeah, that would be this section here.
If
Moving on.
if you didn't need the shell, you could potentially use distroless images that have time zone data and certificates and all of that. Also an alternative.
Mm-hmm.
Oh, right. Yeah. That's a great point, actually. So
we haven't discussed distroless, yes. Thank you for bringing that up.
Right. So that's another option here, right? So what would it be? It would be like from. I'm always bad at remembering this stuff. It's GCR, I think, right? Distroless. Actually, that's a great question, right? There is a whole bunch of them. Which one would we choose and why? Like Google.
Let me send you this link here.
like here we go. It's like 15-ish of them, maybe with some variants. Well, we clearly don't need a Node or Java or Python base here, right? So we can dismiss 60% of the candidates, but still there is static, base no SSL, and CC. Which one would we choose?
I mean, because it's a statically compiled, we do not require libc, so I guess static would be fine. Which I guess is not list, yeah, static, but without the Debian suffix, maybe.
Yep. Yeah, I think that's a very reasonable choice, and I think this particular image is about like 2 megabytes, so it's even smaller than Alpine. Like in absolute numbers, it doesn't really matter, like 5 or 2, but technically it's 50% smaller. What else is special about this image? Yeah, there is no shell, right? So how would we do this?
So I guess we need to move that up to the build stage, and then copy the password files.
Yeah, that's an
That
interesting
could
one.
be an
Yeah.
option.
Yeah, so yeah, like technically, what happens here, even though the command may look fancy, we're just adding some records to the etc passwd, right, and maybe etc group files. So we could actually move this part to the build stage, because in the build stage there is shell.
Mhm.
And then just copy this file back to the runtime stage. And I think this, in a way, emphasizes the downsides of using these images, right? The distroless images. They could be even more optimal, because in this 2 megabytes, what's included? There are certificates, right? There is the time zone database already included. There is an ATC SWD and an ATC group and whatever files, but there is no shell and there is no package manager. So if you want to add a custom user to actually run your application, you need to be creative then, and you need to somehow do this like through some workarounds, and this is something which requires extra Linux and container knowledge. So this is probably the main downside of the distroless images. You need to be like a power user of Linux shell.
Yeah, it's a trade-off. You do more. You have more control. You get to decide what's in there, but you need to know more.
Yep. So you get more or a more efficient image, a more secure image, but at the same time you need to know and do more. Yeah. So one more trade-off, and Alpine still sounds like an optimal choice for this particular case. All right. So a tricky question. We use Alpine latest. How would you like in this case? Maybe it's totally fine, because we probably don't expect any breaking changes in Alpine that would harm this particular binary. But in general, Felipe, what's in your opinion the optimal strategy for pinning or not pinning a base image, the version of the base image?
Yes, well, as you can see in this project, Picot is something I was doing for learning, and not something that I'm going to be running in prod. It was just using latency, which is not the recommended way to do things, right? Because latest can be overridden. Someone can push the same, it can override latest with new changes, right? So my advice here would be just to ping to a specific index digest, not to a manifest digest. So this way we can have these multi-arc images as well working fine. And one thing is, the first time that you pin it, and the other thing is how you maintain, how you keep up to date, right, with the pinning stuff. I think that there's something in GitHub that allows you to keep track, and whenever there's a new version of of latest or any other, you can like keep track. GitHub will open a PR and will suggest a new tag for you with a new digest, right? But that would be my advice. Like, stick to one version of Alpine in this case, grab the index digest and place it there, so that it's kind of reproducible as much as possible.
Yeah, for a personal project like this, I think sticking with Alpine latest is actually a pragmatic choice, right? You don't want to spend too much time maintaining this kind of things, and then the costs of accidentally breaking the final image because something changed in Alpine are, well, it's not even the cost, it's the probability. Like what should happen in Alpine that it actually breaks a single statically linked application written in Go? It's like unbelievable, right, to happen. And at the same time, if you would be packaging a much bigger application, potentially written in some other language and depending on some system and language level packages, pinning the base becomes then much more important, right? Because you don't want to have a break and change. Like, let's say something changes in your, let's say it would be something like this, right? And then you would say latest, right? And then yesterday it would mean Debian bullseye, right? And then today, this is yesterday, right? Oops. And then today it becomes like Debian bookworm, which is a transition between two actually major releases, right? And then like some packages could be gone, some could be added, and all sorts of other breaking changes. So just hypothetically, let's imagine we're dealing not with a statically linked Golang application, but with a web service, right? With a bunch of dependencies, potentially written, I don't know, in Node.js, whatever. We're not definitely using the latest tech, right? And we are, let's say, on Debian. Like, what would you recommend using? Like, there is a number of options, right? We can pin the code name or the numerical version of it, right? Or we can actually go and pin the minor release version. Or we can also pin the patch version. Or we can just do the extreme stuff and pin the actual digest of this image, right? What's your opinion? Like, what would you recommend to people less familiar with Docker and images to go with? And maybe there is no, and not maybe, I highly like that there is no single right answer. But
I think there is not a right answer. But for instance, I do like to pin, of course, the digest. When doing these production images, that's for sure. When it comes to the version of the tag, in this case, 11.9.7 means that if there is like a new patch version, we are not going to grab it, right? So I could like I'm more in favor of doing 11.9, where you get the patches, right? Assuming that the vendor is doing the right Semver thing, because that's very important for security patches. Then you want to grab them without having to change the stack. So something like Debian 11.9 would grab those security updates every time that you rebuild the image, right? I think that there's a very good benefit of it. But of course, if let's say that you do not want to risk something breaking, then you just pin the version and even up to the patch version. Yeah, that would be my advice.
Yeah, I think that's very reasonable. It sounds like you should start with assessing how likely it is actually for your application to break on the patch version upgrade, right? Or on the minor version upgrade, or on the major version upgrade. And I'm sure there are some sensitive applications who would actually care about the patch upgrade, but most of the applications out there will likely be fine if we just go with the major version and that's it. And then we would allow actually the patch and the minor version just bump up every time there is an upgrade in the upstream. And it may sound in a way reckless. It's like, hey, I'm not really pinning something and I'm constantly pulling something new from the upstream, but it's for a reason. It's not because we want to risk it, right? It's because we want to pull the important security patches, because Debian maintainers or whatever other base image you use, they push patches periodically. Whenever there is a new CV or an old CV gets patched, a change is pushed to this repository, right? And if you pin it like this, you will never actually ever pull the security patches. But if you pin it only like this, you would pull pretty much all the security patches for Debian Bullseye or Debian Bookworm, and this gives you like some sort of a trade-off. I think that's a reasonable strategy. Luckily, we don't have to deal with this problem for this particular project, so we don't need to even care about it.
Getting back to my question about using distroless container images, one of the questions there is obviously not having a shell. Is it always a deal breaker? Can you survive without a shell? What do you guys think?
I guess it depends on whether you have problems in prod or not. If you need to investigate something, then definitely a shell is needed in my case, yes. What do you think, Ivan?
I think that was a great point. Again, like in this particular case, can we survive without a shell? Highly likely, yes, because it's a CLI image, right? And a shell is needed when you want to execute commands in a running container. If we're talking about the production stage of the image, like in this case, a running container is a one-off session of this particular like file execution. Would you also want to execute any other commands while this container is running locally? Highly likely not. So then we can live without a shell. But at the same time, why people try to avoid shells is because it's a security threat, right? It increases the attack surface, and then the attacker can just do more stuff because they can execute scripts. In this case, is it a valid threat? Yes, it's a good practice in general not to include shells in your containers. But in this case, it's a locally used CLI tool. like it doesn't really matter if the attacker somehow got access to your local environment, and then they can Docker exec into your containers. It doesn't matter. It's like already too late. If there is a shell or not, they wouldn't even need to run anything in this container because they are already like with access to your laptop or whatever. So
maybe Ivan is a good opportunity to mention cdebug now that we are talking about this.
Yep. Because there are tools that you can use. There are open source tools, cdebug and min toolkit as well. And then there are commercial tools from Docker that they have, a debug
yeah, Docker
command there.
debug, yeah.
And then you have other tools, runtime specific tools like kubectl debug as well, where even if you don't have a shell, you can get in and you can have this experience that's similar to what you'd have if you had a shell, right?
Yep.
Mhm.
Great point. Tools are there, and if you're running a production version or like a service, a containerized service, then you should be carefully assessing the necessity of having a shell there or not, and having all these security threats in mind. And if you decide not to go with a shell-based image, which is a great choice, then you have quite a few tools actually to help you with operating and debugging.
Exactly. And you also have, in addition to the tools, including your cdebug tool, you also have a whole bunch of relevant tutorials about the stuff that we just talked about, using Scratch images, using Alpine images, using distroless images, building and containerizing Docker, Go applications. There are at least 3 tutorials that you have. It's probably a good idea to mention.
Oh, absolutely. Like this is just a Dockerized CLI tool, so it didn't sound, at least to me, relevant to bring up debugging tutorials because we will most certainly have other examples of Docker files in our future episodes, and there will be more server side related, and then of course we would go full on with the debugging stuff.
And we'll add those tutorials to the description.
Yep, that's a great idea. Yeah, I mean, should we go over something else, or was it already
So I'd like to add a
enough
little bit.
information?
I'd like to add to kind of get back to the original idea of the project. Gofile, building without Dockerfiles. So it's an interesting concept there, because if you have like an app, a Go app there specifically, it's about having this lightweight experience containerizing your Go applications that doesn't require all the bells and whistles you would get with a Docker file.
Mhm.
There are other options as well, right? One of them that comes to mind, a pretty popular one, is KO or Co. I'm not really sure how to pronounce it.
KO? Oh,
Yep.
okay, I know that one. Mhm.
Yeah. And another one that's pretty relevant is Min Toolkit as well. It's not well known, but there is a command to build images, and there's a command to build images from binaries, simple binaries. If you have a static binary, a Go binary, and I have a mini demo that I can show if I can connect my terminal. You can point at that binary, and then you can say containerize it, and if necessary, you can say, hey, I also want certificates, and it just does it for you. So yeah, it's good when you have a very specialized flow, to use tools built for that, where you don't need all the bells and whistles. Because when you have all those options, there are more opportunities to make mistakes and not do things the right way, and then end up with images that you probably don't want to have. And if you have a specialized tool designed for a simple tool designed for a specific uh, flow, then you're less likely to make those mistakes. And yeah, because there are not a lot of Docker experts out there, and your regular web developer won't be Docker expert. So all the bells and whistles and capabilities that are there, they just either don't know them or they don't necessarily know how to use them all. So it's good to reduce that and simplify.
Yeah, I think especially one of the reasons why these BuildKit frontends haven't taken off is mainly because it's not easy to write them, in my opinion. You need to have a lot of BuildKit knowledge, and there's no magic behind this. You, as a developer writing this BuildKit frontend, you need to translate all that complexity into, in this case, Go code, right? Which again, it's not easy, but it is, again, it's very powerful because you can abstract all the complexity and just surface only the high-level properties that you want developers in your company or any other people to use, right? And forget about all those run mount, type cache, or bind mounts, right? You could programmatically do that in Go code, and then just provide a better UX, in my opinion.
Yeah. So, and now, since we already know how the Dockerfile of Gofile itself looks like, and it's a pretty massive one, right? It's definitely not the biggest one of them, right? But it's 100 something, no, it's 100 almost lines, and with a bunch of advanced instructions. And this is actually what would it take to Dockerize Go Live using Go Live, and we just compressed.
Gofile, sorry. I think that there's a typo in the.
Yeah, and we just let me fix it. Go. Oh, sorry.
And also the path. Bear in mind that the entry point here is CMD slash in the path line 14.
14. Okay.
Yeah, the path during the entry point is CMD slash main. I think if you open the main.
Yep. Sure. CMD. Go. Yep. So it's like this, right? .go, right?
Cannot remember, to be honest, if I have to specify the main Go or just the full file.
Yeah, it's like details. You can work them.
I think you have to remove the main.go. You have to remove, it's just the directory path.
Yeah. So this is actually, we just compressed 60 something lines of this advanced Dockerfile into just 3 lines of much higher level language. And this is the beauty of these alternative tools. You don't need to write your Dockerfile, and you don't need to know all these ins and outs, like what is even a mount type cache and how is it different from a mount type bind, right? And this command alone is has probably more characters in it than this entire Go file, right? So this is how you would do this more or less. How would you build a Golang application container image using Felipe's Go file? There is KO, right? And it can probably be even shorter there. Well, it's been a while since I used it, but it could be just, KO and dot, which is the current path, or maybe a repository. Kyle, if you could remind me what it would take in Mint.
I'm sending you a message, but the command. It's a little more verbose because it loads the container in the Docker runtime. But Yeah,
Yeah,
mint.
but still, it's a one-liner, right?
Yeah, it's one line. If you take a look at your private message, you'll see it.
It's the same screen, so I
Ah,
rather wouldn't.
okay.
Yeah.
Yeah, one
Anyway,
line.
it's a one-liner, and what's the command without the arguments? Mint
Image build.
image build. Yeah. So something like this. This is the beauty of these higher level tools. You don't need to be a Dockerfile expert. They just do the work, the job for you. Pretty much like this. And the downside is that you are losing control,
Absolutely.
and which could be a good and bad thing at the same time. Like if you only need to compile your image, your application, and put it into a like predefined um, final stage based on a Scratch or an Alpine or whatever, a static distroless image, it's totally fine. I mean, just go and use the KO or Mint or other any like Gofile command tools. But if you need to run some custom setup scripts, like well, not in this example, right? But like
No,
this.
but imagine that you just want to add a new package
Yep.
to
Yep.
to your image, or just to change the linker flags in the Go build. You want to pass, the dash as dash W to remove the book symbols, right?
Yep.
Those kind of things at the moment you cannot do that with this. If you want, then you have to customize this BuildKit frontend to allow that level of customization. And it's always a trade-off. Like the more that you allow users to customize them, let's say that the closer that you are going through the Dockerfile experience again, like
Yep.
the more, right? So, and then you're losing the point. So I
Yep.
guess
And
that
at some point, it becomes as complex as your Dockerfile, and then just why not to use Dockerfile? Yeah.
exactly. So it's a very thin line that you do not want to cross. But I truly believe that this would be like very, very good for companies that need to uh, like enforce in a way a bespoke a standard way of building a specific application, right? So if you want every single developer in your company to build your Go app in a specific way and make that easier for them without having to, copy and paste Docker files, then this could be an option.
Yep. Yeah. So again, it's all trade-offs, right? And you just need to understand the requirements and the capabilities, and then match one to another.
It's interesting that we're ending on the infamous "it depends" statement, right? Everybody
Yeah.
hates it. It's like you didn't answer. Like it depends. But in this case, let's summarize what we looked at, and a few key points, and also let's provide a few references for people to check out once they're done. Because if we look at the a good Dockerfiles.com site, there are a number of good references too.
Yeah. That's the place to go now. Everyone goes to the new and shiny gooddockerfiles.com
The site
and
the site is pretty cool. Yeah.
yeah, that was a collective effort of Kyle, me, and Claude, I think.
For example, that first tutorial that was referenced in the last section, how to build smaller container images using Docker multi-stage builds, and then building container images from scratch, 6 pitfalls. That's a good one as well. And then there was another one about Go applications.
Yeah, absolutely. I would recommend the third one, the building container images from scratch, 6 pitfalls. That's, I mean, if you are like developing in Go, that's a must read. Absolutely. There's a lot of good tips and very well explained as well. So very easy to understand.
And if we go back to the Gofile application, you optimized your container for user experience with Alpine because you ended up with a shell there, and you had an easy way to get your certificates and the time zone information. There are alternative ways to accomplish the same outcome, but you need to do more. For example, you can accomplish the same thing with a scratch image or with distroless, where you copy more things and all of that, but it would be a little more work. So it's not the only way, but it was the easy way and the most UX friendly.
Yep. And given there is no extra security requirements for this particular project, it's probably the most reasonable thing to do. And if you would be running at the same time some backend service in a banking or health insurance company, like you would think twice if there would be an option actually to go with the distroless, which has nothing and produces no vulnerabilities in your scan reports, versus having any other type of the base image. Well, except for Scratch, of course.
Mm-hmm. So it was great having Felipe. If he's still with us, uh, I think he is. He just needed to do something. Anything else we want to add? I think we covered a
I
lot
was
for this Docker file.
Yeah, most certainly it wasn't a short one. I wasn't really following the comments because I was looking at my own screen. Have you looked at them?
There's a couple of comments. One was about the size of the official Docker base images, and another one was about distroless, using distroless. And we covered distroless and the trade-offs with that, and what happens there. And then we also talked about the debugging distroless images when you don't have a shell. There's a way where you would use other tools, and it's possible, and it's gaining more momentum now because more runtimes have the infrastructure to support it. For example, on the Kubernetes side, we have ephemeral containers. That was a blocker for a long time before you could use container images without a shell. Otherwise, you'd be stuck. So now we're in a much better position, but we don't necessarily have enough visibility when it comes to those capabilities and the tools, because I'm not sure if everybody knows about kubectl debug, the debug command in Docker, desktop, cdebug. I'm pretty sure it's not a common name, and Mint debug as well, which can debug pretty much all major runtimes. Containerd, Podman, Docker, Kubernetes, and all of that. So it's about just making sure that everybody knows about it.
Yep. So I think
And
it was a great start,
yeah,
and we will have more of them. But for today, thank you a lot for coming, and thank you, Felipe, for joining us and showing your
Thank you.
amazing project.
yeah.
Thank you so much, guys. It's always a pleasure to talk
So
to you and talk about containers.
one thing I wanted to add is that it's not meant. The session wasn't meant to look for bad things in the Docker file that Felipe has. It's an opportunity to talk about what can be improved or different options and trade-offs, and also about the good things. That's why it's called good Docker files. So we want to make sure that we talk about what's good there. So because it's something that others can adopt, and they have more context about why it's good.
Yeah, absolutely. As we said before, it's not easy to come up with the perfect Dockerfile here, right? But it's always interesting to see in which ways they can be improved. Yeah, so thank you so much for your perspective, for your view on how to make it better. Yeah, it's been great to learn from you.
Thank you, Felipe. It was a pleasure.
Thank you, guys. I
Cool.
think it was awesome. We had some technical difficulties, but we made it.
Yep,
It's very authentic, I would say, not polished or edited. I like that kind of.
exactly. Improvise. Yeah,
Yeah, awesome. Thank you, guys.
cool. Thank
Well,
you.
see
Bye.
you. See you next time.
Bye, everybody.